Alright, what's up guys? So before we even get to trigonometry, let's understand what a right triangle is, right? So a right triangle has one angle that measures 90 degrees. So this angle right here with the box is always going to be marked with the box, right? It measures 90 degrees. So right triangles have this special property or special relationship between the sides. So across, I'm gonna label it real quick. So we have this labeled right triangle. We know from the Pythagoras theorems there's a side length, another side length, and then a hypotenuse, right? Let's just mark this angle theta. Across from this angle theta is the opposite side. The same one it touches, like right here, for example, would be the adjacent right here. And then the hypotenuse is just the hypotenuse. So let's just label that hypotenuse. Boom. So, like I said before, right triangles have this special relationship between the sides. It's sine, cosine, and tangent. For sines, the relationship would be opposite over adjacent. For cosines, it would be adjacent over hypotenuse. And for tangents, it would be opposite over adjacent. Now we know that, we could do practice problems. Let's take a look at this first one. Cosine. We know that cosine is adjacent over hypotenuse. So cosine of theta would equal 12 over x. We don't know this h. So for this one we could just do Pythagoras theorem. 5 squared plus 12 squared equals c squared. That would give us 25 plus 144 equals c squared, which would be 169 equals c squared, square root on both sides, and then that would be 13 equals c squared. Boom. No, c, my bad. So x or c would be equal to 13. So for this one, cosine of theta would be 12 over 13. For this equations, we have to do inverse cosine. I'll show you right now. So inverse cosine, make sure it's in degree. You can check that you're in degree mode, because if you do sine of 30, that would give you 1/2. So now we're good to go. So like I said, we have to find the inverse tangent, because we know it's inverse when we don't know the angle. When we don't know the angle, it's inverse. So I'm gonna write it right here. No angle, inverse. Angle, no inverse. Let's go. So our number is inverse cosine of 12 over 13 would mean this angle would measure around 22.16. Alright, let's do another. Since we're learning about roots right now, I'm gonna just do this one. Sine of theta, we could label adjacent, opposite, hypotenuse. So sine of theta is equal to 9 over 9 square root of 5. Okay, we can cancel these 9's out, so that would be 1 over square root of 5. So we just pop that into calculator. Inverse sine of 1 over square root of 5 would be 26.565. Or if we round, that would be 26.57 degrees approximately. 26.57 degrees. Let's just do this one. It's tangent. We didn't do tangent, so I'm gonna just choose this one. Let's label adjacent, hypotenuse, opposite, tangent of theta would be 9 over 12, and then just pop in the calculator. Inverse tangent of 9 over 12 would be 36.869 or 38.87 degrees approximately. 38.87 degrees. And yeah, so what happens when we do know the measure of each angle? Let's try some practice problems and we figure out. So This one we label adjacent, opposite, hypotenuse. We're looking for the hypotenuse. We don't have the measure of the opposite, so we can only really use cosine, right? Because we have the adjacent, we have the hypotenuse. Cosine 37 equals 11 over x. My bad. So cosine of 37 would be 11 over x. When you have this number in the denominator, right, there's two methods you can take. Multiply by x to cancel out. That would be give you x cosine 37 equals 11. Divide by cosine 37 on both sides. These two cancel out. X equals 11 over cosine of 37. But that method is like too long, you know. I don't want to be doing that on a test where I have to rush. So let's not use that method. I'm going to show you a little technique right now that you might have not known. When we do have this problem, you can just flip these. So x equals 11 cosine of 37. One step, boom, you swap these. It's gonna be the same answer. So x, the side length x, is equal to 11 divided by cosine of 37. That's gonna give you 13.77. And yeah, that's your answer. Let's do this one. I don't know. So we have, let's label this already hypotenuse, adjacent, opposite. We're looking for the opposite. We don't have a value for the hypotenuse. We have a value for the adjacent. Let's use tangent. Tangent 32 is equal to opposite over adjacent. This one, just multiply, and that's one step. 13 tangent 32 equals our x value. So 13 times tangent of 32, that would give you 8.123 or 8.12. Easy, simple. You know what? Let's do this one. This one is flipped, so don't get confused. Adjacent, opposite, hypotenuse. We have a value for the opposite. We have a value for the we're looking for the hypotenuse. So we could do sine 57 equals opposite, or 10.8, over x, and like I said, use that method. X equals 10.8 over sine 57. We pop that in the calculator. 10.8 divided by sine 57. That's gonna give you 12.877 or 12.88. Yeah, 12.88. And yeah, we did a couple of practice problems. That's it. See you in the next video. Have a great day. Enjoy your weekend. I don't know what else to say.